So this video is about finding increasing, decreasing intervals. First step, find the critical numbers. That's going to be where f prime is either equal to 0 or f prime does not exist. We're going to set up test intervals on a number line and find the sign in each interval and then respond to the question if something's increasing or decreasing. So it's the first derivative number line test. All right, where's this function increasing and decreasing? So let's find the critical numbers. This derivative exists everywhere, so the only thing we're looking for are x values that make the derivative 0. Set each factor equal to 0. We have two critical numbers. Okay, the notation that we sometimes see with regard to this is that the slope on f at 0 is 0. We have a horizontal tangent. We just don't know yet if it's a min or a max. And then also f prime, the slope at 1 is 0. Is this necessary? No, but let's go to our f prime number line. But these again are called critical numbers. All right, I'm going to leave a little bit of space here. Try something with you. Okay, so our f prime number line, we need 0 and 1. These are a 0 slope. So doing test values, just choose a negative number. Go back up here to this factored format. Let's just say you plug in -1. This factor will be negative. This factor will be negative, so that is going to produce a positive answer. So now we know that f is increasing on the interval from -infinity to 0. Let's plug in half, because half falls between 0 and 1. So plug in half. That's going to be positive. That's going to be negative. The result is negative. In concluding, we'll build our number line this way. Okay, so what this tells us is up above this, I'm just going to put f and what f's doing. Okay, well, if f prime is positive, then we know that f is increasing. The graph is going up. Between 0 and 1, because we have negative values, the function's decreasing, which means it's falling, and then here it's increasing again. So if you think about these three arrows right here, you can almost draw the graph if you just kind of follow the flow of the arrows. You can almost produce a graph of the function here. All right, and then to finish, f is decreasing from 0 to 1. Let's do open intervals with parentheses. Because, VC is okay, but it'd probably be better to spell it because f prime is less than 0. And then the increasing intervals. Not that we're asked, but we also can see that we have a maximum on f at x equals 0 because f prime changes from positive to negative. You'd also have a minimum on f at x equals 1 because f prime changes from negative to positive. Why is that not? All right, so let's find the derivative to get the critical numbers to set up our f prime number line. This derivative exists everywhere. There's nothing unique, no fractions, no radicals. So I'm only looking for where it equals 0. Common factor? All right, set each factor equal to 0. All right, so one critical number is 0. Notice what happens when you subtract the 1 and divide by 2. The value of your fraction is negative, and when you extract the roots, you're going to have imaginary solutions. So we have no critical numbers that come from that factor. In fact, it's not too bad. I'm going to leave a little bit of space here, and I'm going to draw an F prime number line, only putting 0 on there. So if the slope is 0 at x equals 0, we know we have a horizontal tangent. I don't know if it's a min or a max or neither just yet. Not that that's what it's asking me anyway, but just still something to kind of reinforce. All right, let's do a test value. Something less than 0 is negative, coming back up here. That produces this negative number here. Doesn't matter, you square it, it's always going to be positive here because you're adding 1. So it looks like it's going to be negative. So f is decreasing until 0. Plug in a positive number. The result of plugging it back into the derivative is positive. So we actually have a minimum at x equals 0. That's not what the question asks me, but it is a minimum. Okay. And off to the side, just to remind ourselves, what does this all this mean with regard to f? Well, if f prime is negative, okay, it means that my function, is decreasing. All right, let's just remember what that means about f. If f prime is negative, then that means that f has to be falling. I don't know about the concavity of it, but I know it's falling. If f prime is positive, then we know that the function's increasing. So we have a minimum here. And you can kind of see that as you follow these arrows right here. All right, so down here, we're going to answer the question. Always look back at the question and see what it's asking. F is increasing, not f prime, f. F is increasing on what, 0 to infinity? And because if they ask you to justify, do so. If they don't ask you, then don't waste your time, because f prime is greater than 0. All right, so for problem number 3, we're dealing with tabular data in a table. All right, it tells us that they're giving us selected values of g prime. But what's important here is this. It tells us that g prime is continuous and it has 2 zeros. All right, so in order for us to travel from -4 over to 4 along the x's, there's going to be no breaks in our graph. None at all, because it's continuous and it has 2 zeros. So these are the only 2 zeros that g prime has. These are the only horizontal tangents. That's it, that g has. All right, if the domain of g is also all real numbers, then g is decreasing on which intervals, increasing on which intervals. So let's get that ready. G is decreasing on, G is increasing on. And look back at the question. It doesn't ask you to justify, so we won't have to do that. All right. If G is decreasing, then a lot of students look at these values right here that are negative, and immediately they put -1 to 1. However, there are a lot of x values between -2 and -1. Think about what was told us in the problem. There are only 2 zeros. So this is the only 0. So on my journey from x equals -2 to x equals -1, for these g prime values, all of these values in between must also be negative. Okay, they have to be negative, because if they were positive, then to get to a negative y value here, or g prime value, I'd have to go through 0 again. But I don't have another 0. So really what we want to do is extend and say, you know what, g is decreasing on -2 to +2. So same thing at this other end. You want to extend all the way to 2. Doesn't ask you to justify, you don't have to. If you did, you just say because g prime is less than 0. All right, so what does that mean for us as far as g and increasing? Well, it told us that g is the set of all real numbers. So we need to start at -infinity, go to -2, right up until we get to that 0, and then also again from 2 to infinity. Okay, so if you were asked to justify, you would say because g prime is positive. Okay, so in the next video, we'll take a look at relative maxes and relative mins, but you may want to go ahead and attempt to do some of the problems on your own, just kind of self-assess, see where you're at, and then check the video for the solutions.